Alright, you saw the intro, you saw the title of the video, let's get it going. I gotta go to work in 10 minutes. The case. Do we really gotta talk about this? If we're going with an analogy of comparing a computer to your body, the case is your body, your skin. The bigger the case, the more things you can put into it. The more storage. Haha, big belly. There's not many things that you need to know about cases if you're trying to buy a computer, other than making sure that it can fit every component that you need to put in your computer, and pay attention to the differences in the tower sizes, such as mini, ATX, ATX. You want this attribute to line up with all the other components in your computer to make sure they're compatible. So the CPU. When people say the brain of the computer, they really mean it. Just like the brain in your head, the CPU in the computer calculates logic and performs tasks. Depending on this, we're gonna do this type deal. Performance on CPUs are measured in gigahertz. 1 gigahertz is equivalent to 1 billion cycles per second. Yeah, with a B. During these cycles, certain tasks are being performed, such as adding data together or accessing data from places like memory. These tasks take different amounts of time, and the power of a CPU depends on many factors, such as pipelining, which has been evolving for the past couple decades. Pipelining is performing multiple tasks in parallel during each clock cycle. There are many other factors such as cores and stuff, but I think you get the gist of it. GPU. The GPU is used in parallel with the CPU. A lot of older computers don't even have standalone GPUs. As the demand for higher processing powers were introduced and applications became more intensive, GPUs became their own component. When a GPU is not integrated in the CPU, it's called discrete. GPUs are like mini CPUs, except they focus highly on pipelining like we talked about before. While the CPU must perform tasks in a specific order to ensure that no data gets corrupted, the GPU can break up the tasks that aren't sequence dependent and process those, taking weight off of the CPU's shoulders. Like we talked about before, CPUs can have built-in graphics, but if you're trying to design your computer to handle intense tasks like media editing or gaming, you're gonna want a discrete graphics card. Also, make sure that your CPU and GPU are relative to each other in power, or else one of the two is going to experience bottlenecking, since their performance is limited by the other component's power. RAM. Not talking about trucks. RAM is the memory of the computer. It comes in different sizes and speeds, and you'll probably realize that RAM is a lot smaller than other types of storage. We'll talk about that kind of storage next. This is because RAM is volatile memory, while other types of memory are non-volatile. This means that the data in your RAM is cleared every time that your computer loses power. Now, why would you want that? Well, every application actually uses RAM. Even just booting up your computer requires your operating system to store data in RAM. Random access memory is what RAM stands for, and it kind of describes it perfectly. It's basically like a cache of information that applications can pull at any time they need to. This is why RAM has incredible reading and write speeds, despite its small storage size. If you're buying RAM, you'll probably see that it's DDR4, DDR5. As the numbers go up, the speeds are generally way quicker. I have a weird amount of RAM in my computer right now. I have 48 gigabytes for some reason of DDR4. I would say that if you're using your computer for intense things, you want at least 16 gigabytes of RAM. And try to go for DDR4 or even DDR5. Hard drive. Your hard drive is like the belly of the computer. It stores all of your files, whether they're necessary or not. Let's be real, a lot of your files are not necessary. Solid state drives are hard drives, but with exceptional read and write times, making them access whatever data is in that drive way quicker. Hard drives are usually cheaper due to their slower speeds, but will usually allow you to have like 3 terabytes for $100. Meanwhile, an SSD is like $100 for 200 gigs. Most people with desktops use both and put their most used applications on their SSD. There's also an SSHD, which is literally just a hybrid of the two, putting it into one drive. Those are good options too, since they're usually in a very good price range. A hard drive is the slowest, an SSD is quicker, and RAM is generally the fastest. But with new technology coming out, they're trying to close this margin and make hard drives even quicker, which is awesome. Motherboards. Going with the human analogy, I would say the motherboard is like the heart of the computer. It's responsible for the communication of the other components in the computer. Everything just plugs into the motherboard, and the motherboard handles it from there. It's comprised of all these circuits and slots, and it can look a little daunting when you first see one. But everything plugs into the motherboard. Your CPU actually goes in this little tiny case that rests on the motherboard, with all these little prongs. Messing up just one of those pins can make your CPU not read correctly. When we do a video on building a computer for Jordan, my brother, I'll show you guys more in depth what it looks like. One main thing to note is that your motherboard must be compatible with all the other parts in your computer. I would recommend a website like PC Part Picker, which is linked down in the description below, to make sure that your CPU, motherboard, and your case are all compatible with each other. Cooling. So this is the reason I'm still living in California, but if I was a real hermit, I'd be living in Alaska or Montana. Cooling is a crucial part of a computer's health. In general, people usually have a dedicated cooler for their CPU because the CPU gets very hot. GPUs will usually have a cooler built into them. I think my GPU has like 2 fans on it. I've seen graphics cards with 3, 4, anything to keep it cool. I used to have a graphics card and one of the 3 fans stopped working. Thinking back on it now, I probably could have just substituted a different fan, but I tried to continue using that graphics card and the temperature rose like 20 degrees. It ended up just being unusable and I just upgraded. It was time anyways. Make sure your components stay cool if you want them to perform their best. If you have a little extra dough, I would look into water cooling, but 3 or 4 just regular fans in your case are gonna do fine. Optical drives. If you don't use DVD or CDs, you can skip these. I don't have one. Power supply. The power supply takes your power from your wall, your AC, I don't know, power. It transforms it into usable power for the computer. It stores it and it allocates enough power for your computer to run properly. Most models are above 500 watts. I believe I have like a 650. You don't really need that much if you don't have a lot of components in your computer. But since I'm thinking about upgrading my CPU, I might want to jump up to 800 just to be safe. So in conclusion, all these components are improving over time, and a computer is like your body. You don't want to just upgrade one part of your body without upgrading the rest of it. Even with these guns, I still gotta hit legs. Okay, I already know you guys are tuning out because none of you work out. I'm just joking. I know you guys are all bodybuilders, but I'm serious. If you want to upgrade a piece of your computer, don't cheap out. You don't want to dump over $1,000 on a graphics card, but you only have like a 300-watt power supply. Your graphics card is not going to be happy. Alright, so this is supposed to be a short video, so I'm just going to wrap it up right there. I hope you guys learned something, and if you guys have a really good CPU, let me know down in the comments, because I'm in the market for a CPU, but I'm not sure what to get yet. I'll see you guys in the next one. Have a great day.